In this video, we're going to introduce a theorem called the factor theorem. Now recall from the last video, the remainder theorem states that when a polynomial f of x is divided by x minus a binomial divisor, the remainder equals f of a. Now that gives us a nice shortcut for figuring out the remainder without actually having to do the long division, if it's the remainder that we're interested in. So here's the example we looked at. We divided this polynomial by this binomial, and we got this quotient and this remainder. We said that we could rewrite that as this statement. The dividend is equal to the divisor times the quotient plus the remainder. And then we showed that that means that if you substitute in a, the value that makes the divisor 0, into the function, the answer you get will always be the remainder, because substituting 3 in this example in here will turn this into 0, making all of this into 0 and leaving only 14 as the answer, which must be the same as the answer on this side when you substitute in 3. That was the remainder theorem. Now, what if x minus a, our divisor, is actually a factor of the polynomial f of x? What would that mean? Well, recall that if something is a factor, if the divisor is a factor of the dividend, then you're not going to have any remainder. The remainder will be 0. So here's an example just using simple numbers. 8, the divisor, is a factor of the dividend, 56. So 56 divided by 8 is 7, and in the end you get no remainder. The same thing would happen with a polynomial. If the divisor is a factor of the dividend, you'll get no remainder. Now if you get no remainder, that must mean that f of a is equal to 0 as well by the remainder theorem. If the remainder, when you divide by x minus a, is 0, then f of a must also be equal to 0. So that gives us the factor theorem. Stated the opposite way around, if f of x is a polynomial and if f of a is 0, then x minus a is a factor of f of x. Again, if f of x is a polynomial and f of a is equal to 0, then x minus a is a factor of f of x. So a could be any number. For example, if f of 3 was equal to 0, then x minus 3 would be a factor of f of x. If f of negative 2 was equal to 0, then x plus 2 would be a factor of f of x. Here's an example. Let f of x be equal to this polynomial. Is x minus 2 a factor of f of x? Well, to work out if x minus 2 is a factor of f of x, all we need to do is evaluate f of 2. Notice if this is x minus a, then a must be equal to 2. So let's figure out f of 2. f of 2 is equal to 2 cubed minus 6 times 2 squared plus 3 times 2 plus 10 is going to be equal to 8 minus 6 times 4 plus 6 plus 10 is equal to 8 minus 24 plus 6 plus, sorry, that was a 10, plus 10 is equal to 0. So f of 2 is equal to 0, which means, by the factor theorem, that x minus 2 is a factor of f of x. Now you need to be a little bit careful of the signs, as we were being before when we were dealing with the remainder theorem. If this was x plus 2, then a would actually be negative 2, and you'd have to substitute in negative 2 throughout. So now we've got not only a quick way of checking what the remainder is, but a quick way of checking whether something is a factor. Now once we can figure out if something is a factor, we're getting much closer to being able to factor the polynomial itself. And that's what we'll look at in the next video.